So I don't have a webcam here, but you can at least get voice and screen capture on this machine. So this is a Windows 10 machine, I think, and we're trying to do this project M511 to exploit this vulnerable app called Civ. Now, before I start this, let's talk about why I was unable to do it last week. Civ is unfortunately an old app, and you can tell if you use Android Studio, which I have here. You download that civ.apk, which is over here. If you just drag and drop it into the middle of Android Studio, it will show you the components of this app. And if you look in the live directory, you will see what kind of libraries it uses and what sort of processor it needs. And this is the old one. ARM-E-ABI is 32-bit ARM. Later ones have a different name. So this app is really old, and it was intended to run on 32-bit Android phones. And the problem is, now normally, if you have a Windows machine that's 64-bit, you can run 32-bit code on it for the Intel processors. And the ARM processor has the same property. The 64-bit ARM processor has the ability to run 32-bit ARM code. So you should be all right, but you're not, because Apple, in their wisdom, and the Mac M1, and I think the later ones too, like the M2 and M3, they disabled this. This is a philosophical issue. Windows supports old code on new operating systems because they're commercial. And many companies have some old thing they wrote long ago, like a cash register that runs on Windows 3.1, and they want to run Windows 11 but continue to use really old code. So Microsoft supports that. It's a lot of work, but Microsoft does that because they want to be the standard for business. Apple doesn't care at all about businesses. They only care about home users, so their philosophy has always been they only support the latest version of anything and one version back. Anything older than that, they don't care and they don't support it anymore. So in keeping with that philosophy, they have disabled the ability to run 32-bit ARM code on the 64-bit ARM processor. Now there are emulators available for the Mac M1. I've used one. But this is an unsolved problem. For years, people have been trying to do this. There is, as far as I can tell, there is no way to run apps like this on any emulator on the Mac M1. That's what I tried and failed. So you have to use an Intel-based machine. And the way you do it, which is kind of screwy, is you put on an x86 phone. So I'm using Genymotion, which you'll see is the thing to use. So Genymotion is here, and I made a phone, with an old version of Android, Android 7. All of this is pretty important. This is an x86_64, an Intel version of a phone. So it's using the Intel processor, which is the real processor on this Windows machine, and running an old version of Android. Now that I've got that, that's my phone. Let me get to it here. Okay, that's what this phone here is. Now, it's not got an ARM processor. So if you try to drag and drop Civ on here, it'll first refuse to install it, saying no match ABI found. But Genymotion has a solution for this. And the solution is here, and it's explained in this project. So you try to install Civ on your Android emulator. And if it's using an Intel processor, it will fail. And so you have to install these ARM translation libraries. Now, for some reason, the ARM translation libraries are not available for modern versions of Android. I have read documents that say Android 11 includes this stuff automatically, but as far as I can tell, that is not true, or it doesn't work. So you have to go here and get the Genymotion ARM translation for the version of Android you put on there, which better not be higher than 9. So I chose 7 for this reason. You get the version 7, and you drag and drop that on your phone and reboot it, and now the Android phone itself can emulate the ARM processor and the 32-bit ARM processor, which is what you need. So that's all the hoops you have to jump through to get this old application running. And all right. But it's nice because we can see some flaws here that are not going to see in the official other apps I've got in this course. So that's why I say using deliberately vulnerable apps tends to be very difficult because they tend to be badly out of date, and this is no exception. So I've managed to get Civ working on this phone. And now I'm going to connect. Now, when I installed Android Studio, it installed ADB. I did have to put the path in the path directory. So let me point out, if you are using a Windows machine and you've installed Android Studio, to find the path to the ADB tool, you have to go Tools, SDK Manager, and then it will show you here where they are. So you could go to that directory to run ADB, or you can go into the environment variables and add it to the path. And let me just point that out. That's what I did here. To get to environment variables on a Windows machine, you go to this PC. I think I might have just gone to settings, actually, is how I did. I think I just went here. That's right. I used the search engine. I can edit the environment variables. Now, I could put it in the system account, but I put it in my account. So you go here into environment variables, and one of them is the path. And when you edit it, you'll see, here they are. These are the three that were there, and I added this one. C user, CNET, app data, local, Android, SDK, platform tools. That is the one shown here. So after you do that, now ADB will be available in every directory from the command prompt. So if I go to my command prompt and I clear the screen, let me make this command prompt smaller so it fits on the screen. Okay, now Control C. All right. Control C is not working. There we are. Now I can clear screen. All right, now from anywhere I can do ADB, and the ADB works, showing me a help message. So the Android Debug Bridge application is available. So now I can see if I'm connected to a device with ADB devices. And I see I am attached to a device. That must be my Genymotion because I'm only running one emulator. So I can do ADB shell and get a shell on the Android device. And Genymotion devices are rooted, so I'm in fact a root user, although that's not absolutely necessary for this project. And now I can run Civ on there, and I can control it from the command line here so we can play some games. So that's the game here. So now we're going to put passwords. When you launch Civ, it is a password manager, so you have to give it a master password. So I'm going to give it password 12345678 as the default one. So let me get my phone up. All right, so I'm going to launch Civ. Here's Civ. Okay, so I put in a password. Password 12345678, and then again, tab perhaps. Oh, I guess I've already put it in. I'll try signing in. Password is incorrect. Right. Okay, I'm going to remove this and reinstall it. That's a good thing to do anyway. Let's go to Settings and Apps and find Civ. All right. And I'm going to force stop and then uninstall. Whoa, that's disturbing. All right. It crashed. By the way, this is very common. These emulators are buggy, and they do crash a lot. Looks like there's Civ. Let's see if I can uninstall it now. I do want to uninstall it. Okay, so now it's gone. Now I'm going to put it back on. So I go to my downloads folder, which is here, where I have Civ. And let's get this to the home page. Somehow a key keeps popping up those faces. All right, so I drag it there and drop it. File transfer in progress. It's installed it. There we are. And it by default launches it after installing it. And it should ask me, oh, it crashed and rebooted the phone. So buggy stuff, like I say. Even when it works, it's pretty buggy. So now if I go here, I should see all my, there it is, Civ. There's my app. So I can drag and drop this to make it easier to reach. And now I can launch it. And now I get to put in the password the first time. Okay, password 12345678 and password. All right. Oh, it must include capital letters. Oh, all right, that's what I did wrong. I didn't bother with the capital P because I didn't think it mattered. But you see the policy down there must have capital letters and alphanumeric digits and be at least 16 characters long. So I'll use a capital P, A-S-S-W-O-R-D, All right, and a capital P. 1, 2, 3, 4, 5, 6, 7, 8. And submit. Okay, now I have to give it a pin. I'm going to give it 1, 2, 3, 4. 1, 2, 3, 4. And submit. And now the thing is ready. So now if you want to use this thing, you have to put in the password to log in to your password manager. Now let's go back to the projects. All right. So once you've done all that, then enter the password and sign in. Okay. And we can add a password. Okay, fair enough. So I will sign in here, capital PASSW0ORD 4, 5, 6, 7, 8, and sign in. All right. Now I'm in. Now I can add a password. Now I want to put in CCSF your name and some password. Okay, just so we have something to steal. So I'll add something here, and we'll call this, say, CCSF. And username is student, and the email is student@ccsf.edu. This is all fake information, and password I'm going to use capital P @SSW0RD, and the same thing here. All right, so I'm adding this into the password manager. Now I've stored some data in there, and it shows it to you here. So that's good. Now, all right. Now, we're going to go look at the Android manifest file, and we're going to find the permission. So we'll be looking at the Android manifest. We're going to look at the activities. So I've already got it loaded here. We looked at it earlier to see the libraries that were used. Let me get rid of this SDK manager. Here we are. So here's the libraries that are used. But now I want to look at the Android manifest. And so let's make this bigger. All right. So if you go down here, here's permissions it uses: read external storage, write external storage, and so on. All right. And they got lots of permissions. Allows reading the key in Civ. Here's a special permission specific to this app, letting it read the key and editing the key. All right. And let me see what I'm trying to find here. I'm trying to find the activities. I want to find the file select activity and the main login activity. So I go down here, here's activities, file select. Here's file select, and it is exported. Exported equals true. That means anybody can launch it from another app. You can go directly. And then I have the main login, and that's also should be exported, although it doesn't seem to say that, which is a little screwy. Let me look at my instructions and see if I understand that. Yeah, the main login activity, the first activity is explicitly exported. The second includes an intent filter. Okay, right. This includes an intent filter, which is the launcher. You have to have this. Every Android app has to have this activity. You have to have something which is listening for the launcher. The launcher is this thing here. When you click on this icon to launch an app, that calls launcher. So you can't use an app unless you have an activity that's connected to launcher, and that is the page that will open. And that's what this is. And since it's got an intent filter, it's always automatically exported. It must be listening from signals outside the app in order to do this. So this is also exported to the main login. All right. Now let me check for comments in the Twitch. Okay. How are you able to get the debug bridge working? Yeah, I showed you that. Good. Methodology. Okay. Yeah, it's rooted emulator. Okay. Aside from M1 versus Intel, what is helpful when emulating Android phones for testing apps? I find I don't need anything special for normal apps. Just sort of default phone from a Genymotion or from the Android Studio is good enough to download current apps and test them. The only problem I find is using really old apps like this because things do change. And because developers, of course, update their apps to run on modern phones mostly. Anything that's actually in commercial use, you don't need anything special. All right, those are good questions. All right, so let's go back to the instructions, which are in my browser here. Here, all right. So that's what they are. So we're going to exploit a published activity. Now, there is a published activity called pwlist, and let's take a look at that. I want to see if I can find it in the list here. oh, there's PWList. You notice also here's PWList activity, and it is exported, which is very strange. Now this one is okay. From outside the app, I should be able to launch it and get to the main login activity. But why would I be able to get to something called PWList? That looks like a mistake. And that's what we're going to do. We're going to exploit it. If I'm in the ADB shell, I don't need that. This is the part. AM is Activity Manager. You can start that activity. And since I'm root, I'll be able to do it even with an unexported activity, but I could do it here even without being root. However, in this case, I am root, so it's, I should be able to paste. Maybe not. Control V. I should be able to, oh, to paste into a command prompt, it's right-click is paste, all right? Because Microsoft is very cruel. So I should be able to right-click copy, and I should be able to right-click to paste, and there I am. So this is going to launch it. Now let's get the phone visible so you can see the effect. There's the phone. When I run this command with a T at the end, yeah, then it launches the activity and shows me the passwords. Now, I might think I'm currently logged in, so let's kill the app. If you look at this, you're going to see all the running apps, and you can drag them and you can close them here. So now I know I'm not running the app. If I click this, I'm only running downloads there and settings there. Now I'm not running any apps. So if I was to launch Civ, it would make me log in again. So this is what I want. I've now logged out. So this is the condition where nobody should be able to see my passwords. But because of this flaw, they can launch past the login into here. Now, if I click on this to see more, it's closing and dying because it's imperfect, unable to connect to the service. This may be a problem, but I can see at least some information. And if it was more reliable, I might even be able to see more, like the actual hashed password or something. So this is a flaw. They exported an activity that really shouldn't have been exported. And this is a fairly common flaw. All right, so you see that? All right, now we're going to look at content providers. And let me check for comments in Twitch. Okay, nothing new. All right, so let's go back to here. So we're going to find content providers in the manifest. We're going to find DB and file backup providers, both of which are exported. So let's go to here. Here it is. All right. So content providers, these are activities, which are visible pages. Here's services, which are things that run in the background. And I think it was lack of this service running that meant I couldn't see the passwords. And here are some content providers, file backup and database content, and both of them are exported, which may not be wise. We should be able to exploit them too. So we're going to find the information we need from JADX. Now, I installed Java on this Windows machine, and then I installed JADX. So you can do it on any operating system. So here it is, JADX GUI. This is an extremely powerful program. You're really going to love using it. And so what you do, you can now open an APK file. So I can just go, file open. An error occurred, create a new, this is pretty rude. All right, I may have a problem. Let's see if maybe running it as administrator will help. If not, I may have to demonstrate this part on my Mac. An error occurred, okay. This is unhealthy. Okay, so I'll just talk about this one. It may have a problem on Windows, on some versions of Windows. These machines are kind of old, unpatched Windows 10. Hopefully, if you put on your Windows patches, it'll work better. But anyway, what this does is it takes the code and doesn't just show you the content, it turns it all into readable Java. And you can search the Java. So you can search for content / and find these URIs beginning with content, and you'll see these are the URIs required to use these content providers. So you can see passwords here at this URI. Content, the name of the app, then the name of the provider, and then the folder, passwords, contains the passwords. So we can view the passwords by doing a content query here. So let's try that. if I go to my command prompt, okay, content query, just using one of those URIs, and now I see student at CCSF, username student, and it just prints blob for the password. In earlier versions, it actually showed me something readable, but here it just shows you blob. But anyway, that's showing you some information about the passwords, and I think there might be some way to actually see the contents of that encrypted blob, but I'm not sure how to do it. And if you go to the other one, which is keys, that would be the same command, just ending in keys. So let's just use up arrow and change this to keys. All right, and now I get all that information. Now, if I didn't have root permission on the phone, I would get told I don't have permissions. If I used an unrooted phone, which would probably be better for this task, would be to make an unrooted phone. All right, but now here's the problem. The permissions in here show that this permission is required, this special SID permission to read keys on this path keys. But if you read the developer guide, they will explain to you that Android path means the complete path is specified. And I mentioned it last time, but I'll mention it again. Here's the Bible. You go to developer.android.com, and this is where you'll learn everything about all the features of Android, straight from Google. And the point is, there are many different ways to specify a path permission. And what probably should have been done here was path prefix or path pattern, which would look for anything that contained the word keys or began with the word keys. But by using path, they've specified a permission that only applies to that exact path. So if I just add an extra slash to the end, it no longer matches and it no longer requires the permission. So here, I'm going to see it because I'm root anyway, but if I were not root, this one would have failed and this one would succeed. All right. And by the way, now I've got the login password and PIN for the app, so I can get all the passwords out anyway. All right, so that's the game there. All right. And now we're going to do the SQL injection, which is here. It's a content query to go to the password provider, and we're going to insert an apostrophe, a single apostrophe in quotes. And this is just like putting an apostrophe in the URL bar of a web app, which is a common test for SQL injection. So if I run that one in the command prompt, I get an error message showing SQLite exception unrecognized token. And notice what happened. The apostrophe I put in appears, and now I see some stuff the developer put there. The developer put in this part from passwords. It has confused my data with data put there by the developer, and this is exactly what SQL injection is. Data from the user is put into a line of code mixed with data put there by the developer, and the operating system gets confused. So this means I can inject a proper SQL query here, and here's the one that does it. So I just changed the projection. So instead of just being an apostrophe that breaks it, I put in star from SQLite master, where type equals table, because see, up here, I saw what's coming out here is from passwords, and it showed me select something from passwords. So it's doing a select, so I can just put in what comes, select star from SQLite master where type equals table. This will enumerate all the tables in the database. And this is standard SQL injection procedures. First you get the tables, and I see that there is a table named passwords and another table named key. All right. And now to view the passwords, I need this one here. See if I can scroll to the left somehow. There we are. This content query where I'm going to dump star from passwords. Very simple. And so I put in that. And now I get the passwords, which again appear in this form of blob, but at least I get it. All right. And so that's what I wanted to show you. That's the exploitation here. The only part that failed is JADX GUI, but that'll work on my Mac. So I'm going to stop this video in OBX, if I can find it. Here we go. All right.